Hi, my name is Hyunwoo, and today I'll be going back to fundamentals of Python we've skipped over. This video will be slightly different from our previous videos. Since this will be my last time participating in this organization, I want to make sure the fundamental aspects of programming are covered. Although we covered a variety of topics already, there are a couple things not fully explained. Examples being able to use more than one files in a program, readability, commenting better, free services that you can use later when working with others, and data structures you will need to know in the future. As a little side note, this data structure often shows up with job interviews at tech companies like Google or Apple and so on, but whether you will actually use this data structure in the job is unrelated to the interview. We can first start off with arguably the most important subject we have skipped over, GitHub. One really common phrase you might encounter anywhere in comp sci is the term open source. This just means that the project is readily available for public use. Oftentimes you might see a file labeled README with useful information like the installation process, credits, and so on. To properly use GitHub, we first need to understand several different key terms. GitHub is branch-based. You can think of your repository like a branch of a tree. There is a main branch as well as some other smaller branches that are attached to the main branch. As an example of how branches works, let's say you're making a simple project and it is working correctly. You may later want to change a small part of the program, but this could lead to many problems. Notably, it might end up not working out as intended, and you may need to spend more time trying to undo your changes. Branches would be the solution in this scenario. People that are in your repository will be able to create branches. You'll be able to name these branches whatever you want, but similar to how a variable works, you should probably name it to what it's trying to do. The branch will be a new version of your main branch, which just means it is a save of the project. The benefit here is that you'll be able to save your work separately from your main branch. This means that in the earlier example, instead of having to manually undo these changes, you'll be able to switch back to the main branch or other branches that you want to work on instead. You can also make a branch from a branch and so on. GitHub also provides the users with the ability to commit to branches. Committing means that you are finished with the part of the program that you want to change, and you want to save it to the project directly. This is different from saving your own projects in a solo project that's separate from GitHub. If you're working on this project, you'll be able to save it by maybe pressing Ctrl S. This means that the code will be saved to your local device, meaning that if you go to a different device, you will not be able to access any of your changes. GitHub works somewhat similarly. If you would save how you would normally save a solo project, it'll save to your local device, but this means that any collaborators will not be able to see your changes. Committing, however, ensures that other people will be able to see the new changes, and you can commit using the IDE. The next important command is merging. Merging is pretty straightforward. You'll be able to merge two different branches. One branch will be merged into the other, meaning that one will be overwritten if there are any inconsistencies. You need to make sure you merge the correct branch. Merging is handled by Git, and it uses its own algorithm to determine what should and should not be kept. And I won't be explaining how this process is done, but from my own experience, all merging was seamless and did not cause any errors. Lastly, pushing to origin and fetching from origin. I have previously mentioned that you'll be able to commit to any branch and other people will be able to see your changes. However, this is only done when the other user has pulled from origin. In the process I'll be showing later soon, this is done with a click of a button, so you won't have to worry so much. Pushing to origin means that your local files of the repository will be set to the new changes. But either case, you pretty much always want to do both push and pull origin anytime. Once you've made an account for GitHub, you'll be able to create your own repository by clicking the plus icon and clicking New Repository. You'll be then met with this page. You can choose your own repository name as well as an optional description. I like to personally set this to private since I don't want other people to be able to look at my program. And I often also add a README file so that any collaborators will also be able to know exactly what happened. And again, as a little side note, even though READMEs are optional, this is highly encouraged. Lastly, the licensing. The licensing is out of the scope of this video, and you should most likely go with none unless you're making a fairly big project. Once you have made your own repository, you'll be met with this page. And if you click add file, you'll be able to either create or upload files. Ideally, you would probably create the file first. So if you only name the file a normal file, for example, just testing, it'll be a complete text file, .txt. If you don't want this and you want a Python file instead, you would add .py. If you want any other file, like, for example, C++, the command for that would be cpp, and so on. But ideally, you would not be coding from the website itself. So this is where Visual Studio Code might help. If you do end up wanting to use GitHub, I would suggest downloading two different things. First is Visual Studio Code, which you can find at their own website or in the link below, as well as the GitHub desktop app, and this will be available through the GitHub website. Once you have imported your repository, you'll be able to click Open in Visual Studio Code, which will open up your entire repository in this outline. To use any different languages, you would also likely need to have extensions. For example, syntaxing or compilers, themes, and so on. But most importantly, you must keep in mind that GitHub will not automatically install any APIs or third-party sources, meaning that if you want to use an API, you will have to download that separately from their official website separate. VS Code also offers various extensions for many different languages, as well as some just themes. Once you have made any changes to your program using Visual Studio Code, you can then save it like how you normally would save a solo project, so Control S. And GitHub Desktop will be able to see those changes from your computer, and you'll be able to see it directly here. It says 0 changed files, but if you do change a file, you'll see something else. If you click on that change, you'll be able to see pluses and minuses labeled as either green or red. Green is new additions to the code or anything that has been added, and red will be outlined, and that will be what has been deleted. Once you have seen these changes and you're okay with it, you can then write a summary for the commit, and then maybe also a description so that other collaborators will be able to see and understand your changes better. Now moving on from GitHub, one very important thing that we have skipped over was interactions between files. So let's say you have an entire program called testing.py. In order to better organize your code, you can make a separate file that can interact with other files. So in order to do this, you would simply type in import testing, and now these two files will be able to interact with each other. If you, for example, have a simple method in testing.py and you want to be able to use this function in extra.py, after saying import testing, you can simply say here, you can copy and paste that, we can say testing dot print something, and this will be able to use the method print something from a different file. So the pattern is that from anything accessed in a different file after importing, you would do file name dot, and then however way you want to access that other file. While technically everything can be done on one file, this is not encouraged, as the readability of the code will be significantly more difficult once you get into a longer and more in-depth program. If it's thousands of lines of code, you would want it separated into different files of subjects. And for the final thing I would like to mention that we have not already I've mentioned in the past is a new data structure called hashmap. In Python specifically, this is essentially just a dictionary, which we have covered in the past. However, we did not cover the fact that dictionaries can be used in the form of a list. This seems to be a very common theme amongst different APIs dealing with a very large database and different classes for information. For example, if you're talking about a show, you would need the title, you would need the date of creation, maybe the age rating, scoring, and so on. But in order to store all of this, you would likely use a dictionary. However, because there's more than one show, the way to return this is an input key for a dictionary, and then a list for all the details about the show. As an example of how this might work, let's say we have a dictionary with the key term A, that's the key value, and the resulting value will be apple. Instead of doing this, we can simply make this a list instead. So this could be, for example, apple, comma, and short. And this way, if we need to store more information about the letter A as a key term, by having this as a list, not only will we get the fast runtime of a hash map or a dictionary, you'll also be able to store more information. And runtime does end up mattering on Python because it is generally quite slower compared to some other types of languages like C or C#. One really cool feature about VS Code that you really can't get with any other IDE is GitHub Copilot. Maybe I've talked about this before, but by putting anything as a comment, for example, if we need every letter of the alphabet in the form of a list, maybe you can just type letters of the alphabet in the form of a list, and you can get, letters is equal to, and then every letter of the alphabet in the form of a list. Keep in mind this Copilot is from an AI that will look from your current program as well as your other files, as well as open source programs from Stack Overflow. However, don't let that completely finish your program because oftentimes it's simply incorrect. I believe it only has a 44% success rate. This Copilot will be extremely useful later, since when you do need things like sorting algorithms that are already predefined and better written out in public sources, you can simply type them out as a comment. The Copilot will end up reading the comment, and then it'll try to scour entirety of Stack Overflow for what your need is. This will often simply save your time. Well, I didn't make any projects to show off for the video or as an example for the video. I hope that today's lesson for using Git and GitHub, as well as Visual Studio Code, things about merging branches and so on, I hope these things will be helpful for you in the future.